of data at Bluevine, and his talk will be about going beyond data science teams and why fintech companies really need a data organization. Amit, thank you very much.
Hi. I'm going to talk about building data organization. And the first thing we'll do is talk about why we need a data organization, why not just settle for data science teams. After we settle this question, we'll talk about how to build this type of organization. We'll talk about what are the building blocks of a data organization, how do you structure the data organization, and I'll talk about a couple of challenges you face when building data organization. But first, some PR slides that will look nicer than the rest of the slides because the marketing team did them. First, about Bluevine. Bluevine basically builds the best small business targeted banking platform out there. We provide banking and financial services to small businesses. We've been around for almost 10 years now. We have more than 600 employees over 3 countries, over 6 offices. Over the years, we served more than 500,000 customers and lend over $14 billion in business loans. That's Bluevine. A little about me, and now you see the decline in deck quality. I'm the VP Data for Bluevine. I've been here for 2.5 years now. I spent the last 10 years building data orgs, and I did it in a couple of environments from very new startups to very large corporates. I have more than 20 years experience in data science, although when I started it wasn't called data science. Data science is a relatively new term. I did my master's degree in astronomy, which was great for my career because of the first job interviews. Everybody asked me questions about my master and not the hard technical questions. And most importantly, I am married and a father of 4 boys, including 7 years old twins, which explains why I don't have any hobbies. Before we get to the presentation, I just want to give a disclaimer, and that everything I'm going to say is based on my experience and what worked best for me and for the companies I worked for. There will always be counterexamples. There will also be cases where you say, oh, well, this actually didn't work for me, or this actually did work for me, and that's okay. There's no right or wrong answer here. What I want you to take out of this presentation is what the question you need to ask when you come to build a data organization, what are the principles you need to take care of, and that's it. There's no right or wrong structures out there. But there might be wrong structure, but there's no single right structure. So why do you need a data organization? Over the years, data science became more and more critical for the success of companies, especially in the fintech industry. A lot of time being able to make smart, scalable, automatic, data-driven decision is the key for the success. It's what's distinguished the fintech companies from the older financial institutions. Now, this automation relies on processing very large amounts of data and applying multiple machine learning models, and again, in a scalable and robust way. And these requirements means that in today's world, it's kind of more important in how you implement the models rather than how you research them. And there's a lot of more emphasis on deployment rather than on research. The complexity of today's process means there's a lot more roles, a lot more skill sets that need to be in the company beyond the traditional data science building machine learning model sets of skills. And also raise the questions about what's the best way to organize all these new roles, new teams in the company in a way which is most effective. When things become more complex, it raises the question on interfaces. And interface is one of the 2 key concepts I'm going to talk about. Interfaces are very important. It's what define whether a company performs well or not. So I'm going to start by talking about the connection between usage and structure. And in today's world, as we said, data science are key for the success of businesses. But the processes today are complex. If in the old days, 15 years ago, you look at the data science implemented in a company, it looks something like this. there's data coming out of the user or internal database. It's being fed into a relatively small box that does some kind of transformation and modeling. The model gives back a result. The result goes into a decision layer, which is responsible of the stakeholder, let's say the risk team, and they decide what to do with this result, and they make this decision that is infecting the user. But in today's world, this simplistic view isn't true anymore. It looks something more like this. There's a lot of very complex pipelines out there before the final decision can be made. There's multiple machine learning models running, doing a lot of complex transformation over the data. There's a lot more data to work with these days, as everybody know. And it's true on all three V's of big data, on volume, on velocity of data, and on variety of data. There's also a lot more complexity in the fact that also within this box, there's some decisions layers that route the computation based on intermediate results. So it's not just one black box that you can use. There's intermediate decisions to be made by the stakeholder within this box. All of this really blurred the lines that were easy to draw between what is a data science related area and what is not. And especially for fintech company, there's a lot of emphasis on regulations and compliance, which means there's a lot of more complexity into making sure we have the right monitoring tools in place. So it also adds more complexity to the already complex picture. And complex usage usually leads to more complex structure. So the old data science team doesn't really fit the new complex use cases that we live with today. It's harder to draw the line between the different orgs, so it's harder to say when does R&D stops and data starts, when does business stop and data starts. It creates a lot of new roles or teams because the skill sets required to hold all of this complex box are much more than a single role can hold. And it's very hard to take this and scale it with just a single data science team or a single data role, sorry. So we need a structure that can help us with those challenges. And the structure that many organizations came with is the data organization that really tries to take all the data-related roles and teams and put them in a centralized place. And when you put all the data-related teams in a centralized place, one of the key benefits you get is they speak the data language. They have a common language they speak. And data language or common language is the second important item I want you to take from this presentation. When you put the data engineering team together with the data science team, the data engineering team learn to speak data. They also speak software engineering, so they are in the best place to act as an interface with the rest of the R&D organization because they speak both languages. And this reduces the communication gap that you used to have when you have data scientists talk directly to software engineers. And the same works for other boundaries in the company. It also helps with managing all the meta side of data, all the data monitoring, data governance, data lineage, making sure we meet compliance and regulation, and making sure that we hopefully have only a single source of truth and not multiple. So we answered the why question. Let's talk about the how to. And before we understand how to build data science org, we need to do some kind of structure into the different roles and teams that take part in this type of organization, the building blocks. One way of finding out what are the building blocks is to look at a single dimension view. In one hand, you have the very technical hardware databases side. On the other hand, you have the very business sides where the business decisions are being made. And you want to see how to define roles based on this spectrum. The classical way of doing that, I don't know if you see the lines here, is to say everything that have the word machine learning or models in its name is data science. We put the boundaries there, and we have a data science role. But as we saw, the truth is more complex. And as the usage became more complex, those boundaries started to shift. And as they started to shift, a data science role wasn't enough to deal with everything. Now, the single dimension maybe isn't very valuable for us, so maybe a better look at things is to look at a multiple dimension role, where we take all the key strengths or traits that represent data roles, and we look at, for each team, what's the strength this team needs to be in each role. So here we have 8 of those from statistics, machine learning, operation, data governance, databases, etc. And we can do the exercise of finding out which team we need in the company to have which strengths in this multiple dimension view. This is a very subjective exercise, and it will be different from company to company, but it's a good exercise to do. And when you do it, you can have a better look at the type of roles you can see in a company. In this example, which I completely made up, you can see that the data analysts have some strengths in part of the spectrum. Data scientists have an overlapping but slightly different set of strengths. The same goes for data engineers, and between data engineers and software engineers, there's also some overlap, but you can see there are patterns, and it's easy to define the different roles using those patterns. Okay, so we talked about the building blocks. Now let's put them all together within a data org. And the first need is to draw the line between what is a data org and what's not a data org. And again, we can do it on the single dimension view, as we saw before. And we figure out that the boundaries change, so we no longer look at the data science team, but at the data science organizations. And again, there's no correct answers, and the lines can be different from company to company, and can also change over time within the same company as the company grows, as its business structure changes. But it's really important to understand where to draw these lines, because these lines are what defines the interfaces, where data interfaces with R&D, where data interfaces with the stakeholders, with marketing, with risk organization. And interface define the processes, and good interface and good processes makes you perform better than if you don't have good interfaces. So again, this is a single dimension way of looking at things. Maybe it's easier to do it on the multiple dimensions. And here, one organization might decide to put the boundaries here. All data science, data engineering, data operations are all part of the data org. We don't want data analytics. We want to put them in the business units or in the business functional, like marketing or risk. And we want software engineering and DevOps to be part of R&D. But this is just one way of dividing the roles. Another way might be looking like this. Some organizations say we don't need data ops. We have everything we need in the DevOps teams. But we actually do want the data analysts as part of the data org. So there's multiple ways of drawing the lines, but it's important to do this exercise. So we draw the line, and now let's see where we put the data org inside the entire company structure. And I'm going to talk about 3 different architectures. And again, there's an infinite number of architecture, but this one really defined the spectrum of how data science org looks like. A data org, sorry, not data science. The first one is the centralized one, where we put all the data-related teams that we decided are part of the data org in the same place, the same organization with the same leadership, usually part of the technology group, and it acts as a service org, very similar to the R&D organization. The upside for this is you have very good control on data resources. Everybody is in the same room. Everybody is answering for the same manager. It's easier to make decisions that are data-related across multiple data teams. It's also easy to implement data processes and data knowledge sharing because all the data science teams are part of the same organization, so they can share knowledge, they can talk about problems together, they can really help each other build their own data science domain knowledge. Usually there's faster ID to deployment cycles in this type of organization because you have all the tools you need to put a model inside production, so everything runs really fast. And it's really easier to define this common language that we mentioned because data science sits together with data engineers. They hold the same rituals, the same ceremonies, the same meetings. Everybody learns to speak data, which is important. On the downside, it's harder to connect the data science team to the business side because data science teams are detached from the business units, from marketing, from risk. And that makes them build poorer model, in my opinion, because it's really hard for them to see the bigger picture, to see why we build this model and how we move the needle for the company by building this model. It's also a harder challenge for the company to allocate data science resources. Let's say they're competing, it's not computing, it's competing, sorry, projects between risk and marketing, both fight for data science resources, and now the CEO needs to make this decision. This might work in smaller organizations. It's usually this type of structure fits smaller organization where both the business sides teams aren't very highly developed, and the CEO have time to make those type of decisions. There's a way to mitigate the first downside, connection to the data science team, by deciding to put the data analytics team outside of the data hog and put them as part of the business function, like marketing and risk. Now you have the analytics team for risk, they speak data, they can talk directly to the data scientist, and they have some kind of common language, will help connect the data science team to the business point of view. So that's the centralized. The other side of the spectrum of organization is a distributed structure. In a distributed structure, you put all the technical data teams, data engineering, data ops, in a centralized organization, usually part of the technology org, but data science and data analytics are part of either the business function, like marketing or risk, or the business units, if the company have a business unit structure where you have a banking business unit, you'll have a data science and data analytics business, banking, and a different team for credit. Usually also in kind of a matrix type of management where the data manager will with dotted line management of those teams, but they will actually report to the business unit manager. The upsides here are kind of the opposite of the centralized one. Data science team people have very specific domain knowledge, become very good at creating marketing data science model or risk data science models. There's a strong coupling between data science and analytics. If you see, it's still decided that analytics team are not the same, working together, but they're working on the same business function, so they create a very good relationship. And it's easier to allocate data science resources, because if the marketing leader knows he have 2 data scientists, it's easier for them to plan the next quarter. You know what he can and can't do with the resources that they have. On the downside, there's a challenge in creating the data science knowledge sharing and data science craftsmanship sharing. There's a way we want to make sure that all the data scientists work with the same methodology or are being kept up to date with recent technology updates. And it's really hard when you don't control them. They sit in a different organization under a different management, and it becomes harder. There's also a challenge in creating the common language we discussed, because now data engineering is sitting detached from the data science team, and it's hard for them to build this type of common language with them. And there's usually slower research to development iterations, but for the companies this model, this structure fits, which is the largest size of companies, it's not always a downside to have a slower research to development iteration. Not every company wants to run fast and break things. And now, of course, we have structure on both ends of the spectrum. We have a structure in the middle, and I call it the hybrid structure. And a hybrid structure is kind of taking the best in both structures, where you put the technical data teams and the data science team in a centralized organization, part of the technology org usually. You leave the analytics team on the, either the business units or the business function, like marketing or sales, but you allocate specific data science team to specific business units. When I mean allocate, it means that most of the projects will be dedicated to this specific business unit. When I say most, it's a key word, because unlike the distributed point of view, you have more flexibility. If you need, in one quarter, you have more priorities from other business units, you have more flexibility in playing with the resources, but most of the time will be dedicated to a specific business unit. You get the same upsides from the centralized structure, and it's easier for data science team to be closer to the analytics team because they are dedicated. They work most of the time with the analytics from the business unit or from the business function, so it's easier for them to develop this business understanding of what they are doing. There's better alignment of requirements, unlike this, better alignment of requirements as a result of this. And it's easier to create working processes because they are dedicated teams. On the downside, unlike the distributed model, the BU leaders or the function leaders don't have direct control on resources, because I can say next quarter I might take one of these team members and put it on the other business unit. And it creates a structure which can't really change fast, unlike the centralized one, when you can change things fast and say, okay, next quarter I actually want to do something else. This structure tends to change slower than the centralized one. A little bit about what we do at Bluevine, what type of data org we've built at Bluevine. For Bluevine, we chose the hybrid structure because it fits the company size and the company product structure. Bluevine have two business units, the credit and banking business units. So we created dedicated business unit data science teams, which most of the time work directly with this business unit. It helps me as the leader to align resources. We have the data science team in Israel and the data science team in the US. It helps me divide the responsibility geographically, but make sure each leader has strong data science leader has strong connection to the specific business units. We have a technical teams. We have two types of technical teams. Data engineering, which is the classic software engineers that build data pipelines, data infrastructure like smart queues and things like this. But we also have a team called data operation, which does all the small software development tasks that used to be part of either data science work or data engineering work, but nobody really wants to do them. And for this type of job, we hire recent graduates. That is the first job in the industry. And it's a win-win situation. They get to do all these jobs nobody really wants to do, but are key for the success of the company. This is one of the key teams for the company's success. And they get a foothold in the data industry. And we get a good funnel for talent coming in from outside. For Bluevine, BI is also part of the data org, and the way we treat it is similar to the way we treat data science. It's a centralized BI domain knowledge and craftsmanship point where they are in charge of both the infrastructure for reporting and the best practices for reporting. The actual dashboard building is being done by an analytics team in risk, in marketing, in the different business units, but BI is in charge of the quality, of the processes, of how to build good dashboards. That's what we do at Bluevine. The time? I have some time. Okay. So lastly, I want to talk about two challenges, and unsurprisingly, they are related to the two items I've discussed, I said that are key items, interfaces and building common language. The first one is about interfaces. And we have several interfaces in data organization, usually one with the R&D side, and one with the business side. And as always, when you have interfaces between two organizations, there are going to be gray areas. And gray areas are areas where nobody owns the processes there, and this is where things get to crash. And this is where your production crashes in the middle of the night on a Friday evening. So it's important to identify those gray areas and make sure there's no orphan processes. You'd be surprised at how many of those there are in medium-sized companies that nobody knows about until they crash at Friday at midnight. So it's important to do this actively. Look at the boundaries, identify those gray areas, and make sure that the ownership is clear, and put the boundaries in the right place. However, boundaries aren't static. They change over time. Even if you decide on a single structure, the boundaries still change over time because everything changes in a company. The structure, the business, the type of project you work on. So it's not a one-time exercise to do. It's something you need to do all the time. Go over every couple of months, look at the boundaries, make sure the gray areas are covered. Do this as an ongoing exercise. Internal interfaces also exist because we have several data teams within the data org. It's easier to manage those interfaces because we're all under the same roof, but you shouldn't neglect them because the fact that everybody reports to me doesn't mean there's no gray areas between the different data teams. So it's important to do the same exercise internally as well. And the second challenge I want to speak about is business and domain knowledge. And each structure both the distributed and the centralized one, suffer on one of those areas. On the centralized one, as I mentioned, there's a detachment between data science team and the business needs. And it's important to work on this gap. How do you work on this gap? You make sure data science is involved from day one, not getting a spec already baked saying build this and give me 60% accuracy. No, that's not the goal here. The goal here is to get 90% accuracy, but the goal here is to be involved from day one and have the success criteria for the data science project be the business success criteria. We want this model to help us save $100,000 a month in losses. That's how we should define it. And if you work together with the business stakeholders from day one and not wait to get a spec like you might do, it helps you be more connected to the business side. The second part is if you work in a distributed data structure, then, as I mentioned, how you make sure data scientists know how to be better data scientists, how they share knowledge, how they share best practices, how they keep learning, keep updated with changes in data science technology. And here it's about defining rituals, making sure you have the right rituals of sharing knowledge, making sure you have the right set of structure, like many companies use tribes or guilds to solve this. But you have in the calendar a set of events that make sure data scientists from different business units meet together, discuss their challenges, present their work, talk about what can be done better, make sure you invest in this type of rituals in your company. And again, narrowing the gaps, is important. And again, it's an ongoing process and not something you can do in a one time and forget about it. That's it. To summarize, yeah. Data processes are complex, and complex usage requires complex structure. Data org is a good structure to align all data roles, or most of the data roles. We have to strive to create a common language or a data language which will help us both internally and in the interfaces. The one structure that works best for me is not the right structure that works best for your company, but it's important to ask the right set of questions and don't neglect your interfaces. Thank you.